Greetings and welcome to part 2 of this video module on the one-way analysis of variance. We built on the previous module by actually going in and seeing how the analysis of variance actually works based off the use of means and the variances of each respective group's scores. And so to contextualize this applied example, we can consider the following research question. Does project-based learning promote students' classroom engagement among middle school students? We could easily just flip out these variables and just kind of indicate any kind of independent variable that we can manipulate, such as use of professional development, so on and so forth. And then the dependent variable could easily be switched to any kind of client, student, or employee outcome. But for our purposes, we can assume that we have like a true experimental design where perhaps we're randomly assigning in this case students to one of three conditions, conditions A, B, or C. One of these would be a control group, and we'd have two variations of project-based learning, however those may want to look. But nonetheless, we have three groups that we seek to compare. So we have a single dependent variable that has three levels. And so the hypothesis we seek to test, the null, is that all three group means are the same. The alternative is that they are not all the same. And as we will talk about in subsequent modules, one of the things we think about is, are we interested in comparing any of the specific group means together, or are we just focused on which of the group means might actually differ? But nonetheless, we would probably hypothesize that the intervention is going to, in this case, lead towards higher level of engagement over and above the control group. So for our purposes here, let's look at an applied example when we actually have data. And so what we have here is that we have in three groups. Group one, we see we have 5 people per group, so for each row is a different person. Group 1 has 5 people with the next column over labeled score. So for the first person in group 1, their score was a 16. Person number 2 was a score of 18. Person 3 got a score of 10. Person 4 in group 1 got a 12, and person number 5 got an overall score of 19. And so if we calculate the average, if we add up these 5 scores and divide by 5, we get the mean for group 1, which would be 15, and we get a standard deviation for them. This is the spread of the scores around the mean. And the standard deviation in this case is 3.87. So then for group 2, there's 5 people. So for example, person number 1 got a score of a 4. All the way down through person number 5 got a score of a 2. If we add these up and divide by 5, the average score on the dependent variable for group 2 is 6 with a standard deviation of 3.16. For group 3 then, the first person obtained a score of 2. Person number 2 scored a score of 10. Person 3 got a score of 9. Person 4, 13. And person 5, 11. If we add these up, divide by 5, we get the average score of 9 with a standard deviation of 4.18. And so just tentatively, we can see that it looks like group 1 outperformed group 2 and 3. Group 2 and 3 have very similar scores, with group 2 with an overall average of 6 and group 3 was an average of 9. And so what we see there, those are what we'd call the individual group means. What we also have is we can calculate the overall grand mean for all 15 people, irrespective of their representative group that they were assigned to. So if we add up all 15 scores and divide by 15, the grand mean is 10, with an overall standard deviation of 5.21. And so these are our basic descriptive statistics. The measure is the central tendency with the mean, and the measure of variability with the standard deviation. And what we're going to be doing is kind of looking at how do we use these values to make decisions around whether or not these three group means are statistically equal, in which case we would accept the null hypothesis, or we use this information and we find results that would support that we reject the null in favor of saying that, at least one of the three group means does differ. And so on the previous module in part one, we talked about the component deviations. And this is what we're going to be, this is the whole basis for analysis of variance, or what we call models within the general linear model. And what we're looking at is the differences between observations from the means, and also differences from group means from the grand mean. And so what we have here is the horizontal line 0 out to infinity. This is just a reference for us to kind of just plot the score. So we could just go, 0, 1, 2, 3, 6, all the way up through 15. Maybe this scale goes up to 25 or something. And so what we have there in the values in red, those are our 3 group means that we had on the previous slide. So group 1 had a mean of 15. Group 2 had a mean of a 6. So you see them to the far left. And group 3 had an overall average score of 9. We see there next to group 3's mean, we see y bar sub t. That's the grand mean, or the mean for the total number of participants we have, which is 15. Another value we have here, and this is just for didactic purposes, is just one observation. This is y sub 2 comma 3. So what that 2 represents for group, that's person number 3 in group 2. So the subscript 2 refers to group, and the 3 in this case goes to person number 3 within group 2. And if we go back to the previous slide, that person's score was a value of 8. And then the y bar sub A2, that's just group 2's overall mean score. And so, and again, here's the grand mean. And so one of the things, the components that are the basis of analysis of variances, one is the total deviation. This is the difference between each person's score from the overall grand mean of all 15 people. And so if we just subtract the overall grand mean from that individual score, we see, so if we subtract 10 from 8, we're going to get -2. And this is what we call the total deviation. We can also estimate it's also just the summation of the group mean of 2, so 6 minus 10, which would be -4, and then we add that to person number 2 score 8 minus the grand mean, or the mean for them is 6. So then we would just have -4 plus 2, and that would be our -2 there as well. Just 2 ways to estimate the same value, but nonetheless, person number 3 in group 2 scored 2 points below the grand mean. The other key component here, the variance component, is the between groups deviation. This is the difference between each group's overall mean from the grand mean. And so for group 2, their group mean was 4 points below the grand mean. For group number 3, their deviation score from the total mean, grand mean, was -1, whereas group number 1, the difference there between group deviation, or the difference between the group 1's overall mean score and the grand mean, was 5. They scored 5 points for that group above the grand mean. And so this is, kind of getting at the heart of the analysis of variances, looking at differences, or the way in which scores deviate from individual group means, but then the way in which group means deviate from the overall grand mean. And so in addition to the total deviation, the between groups deviation, we also have the within groups deviation. This is the difference between each person's score from their group mean. And so for this person number 3 in group 2 who obtained a score of an 8, we subtract that person's group mean, or group mean 2's average score from that. So 8 minus 6, in this case we get 2. And so these are the 3 main components that we use to estimate what we call the test statistic, or in this case the F statistic, to help us answer the research question of whether or not the 3 group means are the same, or are they equal. And so this is the whole basis of hypothesis testing here, is that do the means differ above and beyond just chance alone? In which case, there's evidence that our intervention, or the use of this specific, in this case, this project-based learning as an instructional strategy within the classroom, is it significantly raising classroom student engagement above and beyond maybe just traditional methods or whatever the control group looked at. And so the purpose of part 2 of this module was to better dive into the component deviations or the formulas, a little bit of the analysis of variance. In part 3 of this module, we're going to be building on this with an applied example with this data set to go through each step of the calculation of what we call the sum of squares estimates, which are all based off the total, the between groups, and the within groups deviation. So this concludes part 2 of this video module on the analysis of variance.